Okay, BC, hello. So let's go over some of these questions. So number 5, here is the width, and here is the limit of a right endpoint Riemann sum. And here is a right endpoint Riemann sum with 3 subdivisions. It's right here. And then it says, and then actually find what this equals. So this is me just plugging in k equals 1, k equals 2, k equals 3, and then finding the value. And once again, this would be an approximation for this definite integral. Question number 3. So minimum acceleration. We're minimizing acceleration, so we have to work with a prime. So here is acceleration, here is a prime. That means acceleration is always increasing, so the min acceleration would occur at t equals 0 because, okay? And since it asks for the min acceleration, you want to find that value. Total distance traveled by the particle. Here is the velocity sign analysis. And you did have to go over here and find the position function. Be careful that tells you that at time t, I think it's an x, but at 2 seconds, the particle is at position 0. So here is the general position function, and plugging in t equals 2, and position 0, you find c equals negative 2. So here's the position function. Now, to test or quiz, you actually have to write this out, but like the total distance traveled would be s of 1 minus s of 0, which means you'd have to go over here and plug in 1 and 0, etc., plus s of 1 minus s of 3, okay, or you could do s of 3 minus s of 1, take the absolute value, what have you, s of 5 minus s of 3, okay? Average velocity of the particle. Maybe some of you just ask yourself, well, what's velocity? Velocity is nothing other than the rate of change of position. So the average rate of change of position over this interval would be s of 5 minus s of 0 over 5 minus 0. Again, you'd plug that into your s function here. I am not doing that for this answer key because I know that you know how to do that. I think we went over everything from question number 4. I'll do F after you take a little look here. D did involve U sub. C involved U sub. I just did it very quickly in my head. Here I did U sub this way. E involved U sub, okay? Okay, so then F is really interesting. So F, find the value of B, and I'm saying B can't be negative 3, so you just can't give me the same value up there, where this would equal 0. So all I'm doing here is just evaluating the left-hand side of the equation. And then I have this, which is the left-hand side set equal to 0. And I was about to start doing this because you're going to have a quadratic, and then you want to just, I think it's actually ends up being factorable, so you'll get the answers that way. You can also do it graphically. So I just graphed negative x plus 4, and that's this line. And the net signed area from negative 3 to what would equal 0. And all you have to do is just kind of figure out what value here of B would give you a net signed area from negative 3 to 11 of 0. It ends up being B equals 11, just using some symmetry. But you could also do it this way. Do it out. Okay, let's see. Number 6. Here are the answers. Don't think that I need to go over anything here or explain anything. This was like the average rate of change in people, right? And because it's a negative number, I want to write this cleanly. So it's between 801 and 805, the number of people in that harmony is decreasing because this number is negative at the average rate of 3 people per minute. And of course, the word decreasing implies the negative. Okay. Again, leaving at the rate of 7 people per minute, leaving implies the negative. Okay. Okie dokie. And then here is the answer to question number 1. So equation of the line tangent to capital B at t equals 4 is a horizontal tangent line, y equals negative 2. The indefinite integral of capital B is the little b function, so this function would tell you the number of bunnies in the jar, okay? And the question was, find when is b of t concave up. you want to know when capital B prime is bigger than 0. So that's on the interval of 4 to 6 and 6 to 8. 4 to 6 and 6 to 8, because that is where B prime is positive. And capital B prime is little b double prime. Okay? This number here, so the net signed area from 6 to 14 of the capital B function, that would be because it's capital B is always positive, that tells you that 14 bunnies have entered the jar between 6 and 14. And then you're told that at the start of when you keep track of time, there are 11 bunnies in the jar. How many bunnies are in the jar at t equals 6? Well, so from 0 to 11, that means, let's see, ready? This area represents the number of bunnies that enter. This area is number of bunnies that leave. And then you want to add the 11, which is the initial. So at the end of the day, the jar has 16 plus 2 pi bunnies. Very disturbing thought. Between 2 and 8, when is the cave least occupied? That means when is little b at a minimum. And little b prime is capital B. So between 2 and 8, here is the sign analysis of little b prime. Min occurs here by first derivative test for extrema. Number 2, here's let's see, again, average rate of change of velocity, if you wanted to do that. Indicate units, here's that work over here. Here is rocket B, you had to find the velocity, you had to find C. Here's the specific velocity function, and at 80 seconds, rocket B is at this velocity. At 80 seconds, rocket A is at this velocity, so rocket B is traveling faster. And then here is let's do part B. So this is actually really neat. So this is strictly a reading question. So it says, use a midpoint Riemann sum. So we never did any math with midpoint Riemann sum, but I do think I do know you understand what a midpoint Riemann sum means verbally. So we're going to approximate the definite integral from 10 to 70 of the v of t function. So all I did here was I sketched the v of t functions from 10 to 70 with these dotted points, and who knows? I mean, I just kind of said like, okay, so at 10, this is 14, and then this is 22 at t equals 20. So this is 10, 20, 30, 40, 50, 60, 70. So here are my 1, 2, 3 subintervals, right? And if it was asking me for a midpoint Riemann sum, if it was asking me for a right endpoint Riemann sum, I would draw my height of the rectangles like this, right? And then I would use the table up here, for example, to find what this height is. This height is right here is going to be the velocity y value when t, so that height is 29. But this is asking me for a midpoint Riemann sum, which means I want to go to each middle of each interval and draw a rectangle like this. I'll make it a little bit fatter. So here is the first rectangle, midpoint Riemann sum. Here's the second rectangle. Here is the third rectangle, okay? And each of these widths, of course, is 20. So what's the height? Well, the height of this first rectangle is the velocity, or the f function value at t equals 20, which is 22. So the area here is 20 times 22, plus this area here is, let's see, 30, is this 40? Yeah, t 40, so 40, that height is 35. 20 times 35. So then what you're going to do is you're adding up these three areas. And when you add up those three areas, okay, you'll have found the approximate value. You can do that arithmetic on your own. It's this area plus this area plus this area. That'll be an approximation for this. And then you want to say, what does it mean in terms of the rocket's flight? Well, this area of the three rectangles would be an approximation for the distance traveled by the rocket between t equals 10 and t equals 70. Okay, goodbye.